Just got to cut these off to give some supports to the double stack battery. Alright, got the battery wired up. Doesn't look half bad. I had to cut and extend all the wires, and then I just wrapped them in wire wrap. Looks pretty decent. And this one is going to go on the bottom, so I had to pull the wires out from this side so that they would not get crushed, because before I had them coming out like this, all as a jumbled mess. But then I realized frame on frame, that doesn't work. So I had to extend them, and I'm going to have the BMS box here, zip tied on, and that's about it.
I'm not going to turn it this way now.
Getting there.
Yeah.
Well, just hold on to it with the pliers and turn the machine on.
I'm sure that's very OSHA approved. There we go.
Awesome.
1, 2.
Line in center.
The seed value.
Button Z? Okay. Slow it down. And you're just doing everything with a 1/2 inch infill?
Yeah.
Okay, cool. So that's the pulley, that's the gear, and it's a near perfect fit. Just got to get it deburred. There we go. Yeah, so now we just need to turn that down to 1.65, and then we'll slip that gear on. This is the 16 tooth, it's done. Gonna get that welded up.
Real quick.
2 chains. Got the sprocket all machined and welded up. That's on, just need to tighten it. And then I have to change out the dummy starter relay, or the pre-charge relay for the real one. And I might just run it off just one battery pack right now, just to see what it does. And I don't have a throttle yet, that's in the mail, but I will be using my key switch box, and so I can get that going. Awesome, awesome. Alright, so just got the nut on the motor torqued up, and one of the things I'm noticing is that when I put torque on that motor, because I've got such a huge span between the 2 pillow block bearings, the axle is bending. It's sitting there pulling in, and it's creating a lot of slack in the chain, so my 3/4 axle may not be big enough for that span. And what I'll probably do, what could I do? Yeah, I'll probably just weld in some supports and then just weld in some new brackets. That'd probably be the easiest thing to do versus buying new axle and new gears and everything. So I'll just take it over to my buddy's house that has the welder, and we'll just weld some supports up and pull the supports closer in, if that's a problem, which I'm sure it will be. I mean, that motor doesn't put out a ton of torque, ton of RPM, but not a ton of torque. And the other thing I'm looking at is getting a new controller, because right now, like I said, I can only spend a 5200. That's an kV of about 32 for this motor, and this controller can only do 180 volts max. I'm looking at getting another controller and customized brain for that controller. So I'll continue using this, throw a new controller on here, and a little brain to control that controller. And with that, I should be able to get to 14,000 RPM on that motor. With 14,000 RPM on that motor, I will have to significantly re-gear, because it's geared for 5200, so that's 2.8 times. That's a lot. It's a lot faster. So right now I'm doing 30. So if I do 30 times 2.8, that's at like 70. Yeah, that's too fast. So I'll have to get a much bigger gear up here and an even bigger gear down here, and possibly a smaller gear and a smaller gear. I can go to a 11 tooth. I think it's the smallest I have right here, but I can go to whatever I need here. I can make that 70 tooth if I need to. But yeah, getting close, getting close. I'm excited. And I forgot to mention, as I was sitting and recording this, these came in. These little guys are my temperature sensors for the Kelly controller. The Kelly controller does not take a 10K pot, and these guys are the opposite direction. These are a linear, a positive direction on temperature. So as the temperature goes up, the resistance goes up. A 10K pot, as the temperature goes up, the resistance goes down. So I can't even use the 10K pot with some arbitrary set point that's some ridiculously high temperature, because they'll never meet, because they're going in different directions. Alright, so now I've got this battery on the bottom. It's got all the nice pigtails on it coming out the front, and I got the main negative coming out the back. The other battery is going to sit on it just like that, because there's my positive that's open, and there's my negative that's open, so it's going to go from there to there through the breaker. So let me just go tighten all these up, and then I'll drop the battery on top. You ever notice that the helping hands just aren't good enough? They're not sturdy enough, they're flimsy. That, and with the little heat shrink that's on there, you'll burn them. So I got the helping claw right here. It's just a pair of pliers gripped onto the table with a adjustable zip tie, or a reusable zip tie right there, because I hate throwing away zip ties. And then that acts as like a huge spring, and it holds everything real well. I don't do that many videos of me working, just because it's kind of boring watching me work, but I notice a lot of people do that. The difference between someone who knows how to solder and someone who doesn't is flux. And this flux is pretty nasty. But man, look at this. I mean, I can push on it a little bit and not move anything around. So, get flux all on that guy. solder. Almost need another helping hand to help me feed the solder in. Ooh, that's hot. Toasty. And then I just give it a little tug, make sure it's good. Yep. There you go. And then I will put some heat shrink on that, just protect that guy right there, and it's good to go.